The Airbus factory in Hamburg-Finkenwerder, one of the largest and most modern aircraft production sites in the world. Its 16,000 workers and engineers work on the production line for high-tech jetliners. In just 5 weeks, the team can fully equip the gigantic A380, including its exclusive first-class cabin, containing a bar and luxury bathrooms.
Every tiny scratch needs to be reworked so that we have really a perfect appearance of this cabin.
During the test flight, the pilots and engineers push the plane to its limits. They check whether everything in the cabin works as intended and test the aircraft's air pressurization system.
Ready? Then we depress now. Please. Pack 1. Check. Pack 2. Check.
In the modern paint shop, the paint is applied layer by layer until the jet's exterior is gleaming new.
Maximum allowed thickness is 330 microns, so quite thin.
The Airbus employees have one goal: building high-tech aircraft faster and cheaper than ever before in the face of intense competition. Airbus in Hamburg. Its 16,000-strong workforce make it one of the city's biggest employers. The factory premises have the infrastructure of a small town, with a fire service, medical center, a harbor, and of course, their own airport. Here, the giant A380 is fitted out. Also on site, sections of the A350 fuselage are assembled. Various models of the A320 family are also built. Airbus's range of commercial aircraft is the company's most successful product line. More than 12,000 jetliners have been delivered so far, while thousands more orders are waiting to be fulfilled. Stuart Wilcox leads the customer management of the A320 production line.
Here we are in our Hangar 9. This is a flow line. Flow line is basically a long line of aircraft that start at one end in pieces and come out at the other end as a pretty much finished aircraft. Each station, and we have 4 stations here in our flow line, has a particular amount of work to be completed. Once this work is completed, it's moved then on to the next station where more work is completed until we finally have an aircraft which is ready to be taken out of the hangar and tested, ready for its flight.
The assembly line works around the clock in a 3-shift system. The 4 stations are each managed by a team leader who must ensure that the schedule is rigorously adhered to. Each station has just 2 days takt time to complete its part of the production process. At Station 40, the 16-meter long wings, which have reached the factory just in time, are attached to the fuselage. The first step for the engineers is to determine the exact position where the wings are to be attached.
There are several places where I have to ensure that there's no contact, so that no damage occurs between the wing and the fuselage. That's why I have to say stop from time to time. There might be contact. We need to go up a bit, or a bit to the side.
With an accuracy of up to 0.4 millimeters, the wings are attached to the fuselage of the plane.
Once the wing has been installed onto the fuselage, our shop floor experts measure the position of the wing. We then go in with mirrors and other devices to make sure this wing is perfectly positioned onto the fuselage with no type of stress or gaps or anything else which we shouldn't have on this, in this junction. Once this has been performed, we are ready to rivet the wings onto the fuselage, and then we know that they are in the correct position and have no issues then further along the line.
20 centimeters, 10 centimeters, and we're in place.
More than half of all A320 family aircraft in the world are assembled in Finkenwerder. The front section of the fuselage is delivered from Saint-Nazaire. The engine pylons come from Toulouse, and from Hamburg, the tail section. The vertical stabilizers are made in Stade, while the flaps are sent from Bremen. The wings are assembled in Broughton in the UK. The horizontal stabilizers come from the Spanish city of Retafe. All in all, 7 different construction sites build and deliver the parts for final assembly. In the meantime, the engineers are checking the fittings.
To install the wing, we use so-called corner fittings. These are large sections of aluminium material which have form which is unique to each aircraft. They have a general form which arrives here in Hamburg, and each one is then measured and remeasured and fettled in order to have a perfect fit onto this aircraft. Once that's been performed, we can install this part onto the aircraft.
Team leader Dennis Tietjer monitors the installation of the pylons and engine mounts. This is an important milestone in the construction process, if there's to be any hope of staying on schedule.
How's it looking, lads?
Nearly done.
We're nearly finished here, so we'll be ready to mount in shift 4. Fantastic. Good work. See you later. Right now, we're exactly halfway through the 6 shifts, the 48 hours that the aircraft spends in construction here. Now is exactly the moment when we can see whether we're on schedule. If we're ready to tact, which we are, then it means that construction's on schedule and that the assembly cycle is running smoothly.
In a different part of the site, the latest addition to the Airbus fleet, the A350, is being fitted out. Hall 261 is home to a large-scale assembly line. At 6 separate workstations, the roughly 13-meter-long sections of the plane's fuselage are fitted out, up to a certain level of completion. Then, at predetermined intervals, or tacts, each section moves up the assembly line. When a section is fully equipped, it leaves the hangar.
Good.
Production manager Michael Witt leads a crew of 130 aircraft engineers working in a 2-shift system.
Here in Hamburg, in this hangar, we perform the system installation of the so-called forward section, which starts behind the cockpit and which ends in front of the wings, and the rear section, which starts behind the wing and ends at the rear end. System installation is the installation of mechanical systems like air conditioning pipes and electrical systems, so harnesses for data transfer.
The transport team brings a new empty section into the hall and puts it in position 1 in the assembly line. The engineers use a joystick to precisely maneuver the extremely heavy load into its resting place. When the sections arrive in the hangar, they are completely empty, except for any load-bearing structures. Inside the fuselage, the mechanics use a mirror ball to guide a finely calibrated laser beam to preset measuring points. A measuring instrument then determines whether the hull is perfectly straight.
So in A350 product, we have very tight tolerances to have a very nice cabin at the end. For that, we have a leveling of the section, of the fuselage section, to install the modules and at the end the cabin B brackets, that everything fits well at the end. We do that with a laser measurement, so to achieve very tight tolerances here, already in the major component assembly.
The fuselage must be completely straight, so that large components can be correctly installed. The measuring process is repeated several times and then readjusted by another engineer 1 level further down.
There we have tolerances. First we have the leveling of the section, and then we integrate the modules to specific attachment points, which we measure on top.
The first large component is floating through the air, the so-called center module. It already contains a number of other key components, such as the plane's air conditioning. This module is prefabricated at a separate assembly site and can now be pushed into the fuselage in one piece.
So specific for A350 is that we have the so-called modules underneath the upper shell. Modules is an assembly of frames which we equip then with all the systems inside, so mechanical systems like air conditioning pipes and electrical harnesses. We do that outside the section to have, during the ramp up, an opportunity to move the production line faster. So we have decoupled a big work package from the speed of the production line, and another advantage is that we have very good ergonomic working places where we don't have to work overhead, but we can sit or stay in front of the product.
12 days later, the sections are completed. Now the engineers are preparing them for onward transport. Beluga freight planes carry the individual sections to Saint-Nazaire in France. In this battle of the Titans, Airbus, with its fleet of modern aircraft, has steadily caught up with its rival Boeing over the last few decades. Airbus produces around 800 passenger jets per year. The modern A350 and the popular A320neo have contributed to the company's success and growing order volume. It currently has more than 7,000 new orders waiting to be fulfilled. Back to the final assembly of the A320. The previous day saw the wings attached to the fuselage. Today, they will be fastened securely in place.
Once the wings have been withdrawn from their initial drilling position, all of the holes and the interface areas are very closely scrutinized by our quality experts. There is a complete cleaning of the area performed to make sure there's no parts, metal or any other parts which shouldn't be in the process. Once that's been performed, we install sealant into the entire junction area before we finally install the wings back into their final position.
The wings and the hull are glued together. The bond must be extremely secure and able to withstand both vibrations and high fluctuations in temperature.
We need to work fast because we need time to join the parts together afterwards. The biggest problem is actually the temperature. The kit is solid after 4 hours if the temperature stays at roughly 20 degrees. If it goes up 2 or 3 degrees, then you can reduce that time by a third. That's why we need to hurry a bit, which of course puts us under time pressure.
Deswegen sollte man sich schon ein bisschen beeilen und es ist natürlich auch ein bisschen der Zeitdruck.
The 50-person crew has 2 days to complete their work before the aircraft moves on to the next station. The computer has saved the position data recorded a day earlier and now guides the wing to its designated position.
At the top we see the actual value, below the target value. If they match, then the wing is in the exact position we need it to be.
The bond needs to hold for the entire lifespan of the plane. Passenger aircraft can be kept in service for up to 40 years.
Set!
Fine at the back.
Everything okay? Stitch!
Aviation is not yet advanced enough to rely solely on glued components, so each wing is fixed to the fuselage with a further 2,000 titanium rivets.
So there is a definite list of activities which need to be performed on the aircraft. The aircraft can't really be moved from the station until the work has been completed, and so each individual task will be measured by our controlling people to make sure it's performed on time. And for sure, we do have quite a bit of pressure to make sure this work's completed when it should be completed. Each one of our stations here will move to the next station after around about 2 days. These 2 days are very strongly coordinated and controlled within the station, which means each part of the work which is required to be done at this station has a very strict amount of time which needs to be used for this part.
Now it's time for the engine pylons to be fixed in position under the wings. They connect the wings to the engines.
The pylons are delivered per aircraft, and they have a specific serial number per aircraft. That means they are destined to be fitted on this particular one aircraft. If one gets damaged, it's unlikely, but should it get damaged and we can't install it onto the aircraft, this can have for sure an impact in our complete flow line. We can for sure take a different pylon which was destined for another aircraft and install it onto this aircraft to recover the situation, in which case we do have then some paperwork to complete.
We're near the end of the designated takt time, and there's no longer any room for error. But something has gone wrong.
It's pretty tight. It's looking tricky. Clevis is stuck somewhere. Was he caught? Yes, now stop. Yes, that's better.
Installing the pylons onto the wing is a very complicated and very detailed and very accurate job. Our experts here will take the time with our jigs and tools to make sure that these pylons are in exactly the right position. This, as you can imagine, is extremely necessary because afterwards we will hang the engines from these pylons and they must be in the right position. We take the time on this job and we make sure through measurement and double measurement that they are exactly in the position they're expected to be in.
The team has kept to the 2-day takt rate. The planes can all move forward one position, and the aircraft at the front of the line now leaves the hangar. It will be transported to another hangar where the engines will be mounted.
When we started manufacturing aircraft here in Hamburg in 1992, we were at a takt rate of around about 5 or 6 days per station per aircraft. We have 8,500 aircraft already built and a huge backlog of aircraft ready to be built, and really our customers need their aircraft. So we permanently look for new ways of working, for new technologies, increasing our number of final assembly lines and increasing how fast we move the aircraft from one station to the next. We are currently at a rate of 2 days per aircraft per station, and as you can imagine, these aircraft rapidly move along our flow line until they're finished.
At the Airbus plant in Finkenwerder, the world's largest passenger plane, the A380, is fitted out. In just 5 weeks, the engineers in Hamburg will transform an empty fuselage into a luxury megaliner designed for around 500 passengers. It will, however, be one of the last of its kind to be manufactured here, as Airbus has decided to discontinue the A380. Lars Fischer is in charge of cabin furnishing.
The basic aircraft is assembled in Toulouse, so they are putting all the sections together, the wings, vertical and horizontal tailplane, landing gears, engines, and producing the flying aircraft. So after clearing this for flight, they are transferring the aircraft here to Hamburg, and we are receiving the aircraft empty with some just amenities for the flight crew, but the blanket, floor panels and open side walls with harnesses, pipes, ducts, open all the electrical wiring. And then we are installing step by step.
Preparing the plane for outfitting also requires the engine fuel and various oils to be drained beforehand in order to prevent the engines from getting damaged.
Compared to an A320 family aircraft, we have a much higher complexity in the cabin. We have 3 to 4 class layouts, first class, business class, premium economy and economy class, where single aisle usually have 1 or 2 classes, maybe 3. So this is a big challenge, and the interdependencies of an aircraft which has 3 stories, upper deck, main deck, lower deck facilities, which are all connected. We need to deal with a lot of complexity in the management of all these processes, as well as the technology, where all the systems are connected, and we need to have everything in mind if we're pressing a button on the upper deck that this could have an effect on the lower deck.
The upper and lower passenger decks are connected with a staircase. Due to its sheer size, installing this component calls for patience and precision. The fitters need to move the staircase into position from both levels simultaneously and carefully fix it in place. Rectifying any mistakes later will be extremely difficult.
So, both of the bolts are fixed? The hardest part is done.
You just need to secure it underneath.
Right, now we're going to align the staircase. It'll be fixed at the bottom to the floor.
The interior fittings are delivered by external suppliers. The fitters install them carefully and then cover them up to avoid any damage occurring.
The side walls, the ceiling walls, they need to be assembled here in Hamburg, and we need to put them in 5 big pieces in order to install them step by step so that the whole stairway is completed in the first days.
The 2 passenger decks are around 50 meters long and 6 meters wide. The aircraft mechanics clean every window and carry out a visual inspection.
Before starting with the cabin installation, we are checking all the areas behind the cabin panels, including the windows, if they are really clean and good for delivery, so that we don't have to reinstall the cabin just to clean up a window in the later process. So this is our risk mitigation, that we have to reopen a cabin in the further process, checking everything before starting with our installation.
The A380 was intended as Airbus's response to the Boeing jumbo jet. Yet the market has changed. Now the trend is towards smaller and more efficient passenger planes.
I really like this aircraft for its dimensions and this complexity, this calm behavior during flight. When we looked at the wings, these huge wings where you can look from the stage over the wings, this is an amazing impression. And flying with that aircraft is really a wonderful experience with this calm cabin and this comfort which is delivered through this aircraft.
Airbus Hamburg is one of the 3 largest aircraft production sites in the world. What makes it unique is its own on-site airport. 5,000 takeoffs and landings take place here each year. Air traffic controller Christian Stubber is working the late shift. He and 5 colleagues take turns coordinating the flight movements.
Airbus 37 to Alpha, thinking weather tower, wind 120 degrees, 7 knots, runway 23, clear to land.
Stubber has to constantly coordinate with his colleagues at Hamburg's other major airport. And this special location on the banks of the Elbe requires unparalleled concentration in the control tower. A pushback tractor pushes Beluga No. 5 out of the hangar. The freight plane then makes its own way towards the runway. Once the all clear comes in from the control tower, the Beluga can take off. Some 2.5 hours later, it will arrive in Toulouse with its precious cargo. From Finkenwerder, there is a daily shuttle service to Broughton in the UK, to Bremen, and to Saint-Nazaire and Toulouse in France. The Beluga freight planes also collect and deliver cargo from Airbus's Spanish plants in Getafe and Seville. After Finkenwerder, the Airbus plant in Toulouse is the company's largest. It's home to the Airbus headquarters with 21,000 employees. Although it's part of the A380 production line, Toulouse is also where the final assembly of the A350 takes place. Today, parts for final assembly are delivered from Bremen. Ground coordinator Baptiste Dronet takes receipt of the incoming cargo.
Ce Beluga arrive de Bremen.
The freight plane has just arrived from Bremen. It's carrying a wing for the A350. We're going to unload it now. Then we're going to load the plane with transport racks for the A320 and A350. The Beluga will fly on to Saint-Nazaire. Generally, although it depends on our schedule, we load and upload up to 7 Belugas per day.
The carbon fiber wing weighs around 2.6 tons. This is significantly less than previous models.
Donc nous avons le Beluga numéro 3.
The wing that we're currently unloading for the A350 is a good example of the cooperation between our different sites in the UK, Germany, France and Spain.
Entre anglais, français, allemand et espagnol. La partie inférieure de la voilure
The lower wing cover for the A350 comes from Illescas in Spain.
en Espagne. La partie supérieure, quant à elle, est faite
The upper wing cover from Stade.
à Stade en Allemagne. Ces deux parties
The
sont
wing is put together in Broughton in the UK, and then the flaps are installed in Bremen.
pour ensuite être expédiées sur Brême, où là est effectué le montage des
Now the finished part has arrived in Toulouse and will be taken to the final assembly line of the A350.
où elle est déchargée puis envoyée sur les lignes d'assemblage 350 à la constitution finale.
The A350 was 8 years in the planning and design stage. Each plane costs around 350 million euros according to the Airbus price list. The cockpit was installed in Saint-Nazaire. Here in Toulouse, the fine programming is carried out. At this station, the wing, which has just arrived from Bremen, is mounted and firmly connected to the fuselage. Each wing is 32 meters long and is first glued to the hull, before being secured in place with thousands of rivets.
What's special about this plane is its lightweight construction. Many components are made from carbon fiber. Nearly the entire fuselage and the wings are made from CFRP. Other aircraft have a lower proportion of carbon fiber parts. Initially it was difficult to work with this material. Nowadays it's commonplace. It has a lot of advantages when compared to aluminium. The A350 is a plane with some amazing features. It represents the future of aeroplane construction. It's really a next-generation aircraft.
For Bonnet, the A350 stands out as an environmentally friendly and cost-effective jetliner.
One reason for the low fuel consumption is, apart from its lightweight construction, the design of the wing. The wings are optimized, as are the wingtips. And then we have the new engines, which also contribute to low kerosene consumption.
The latest model of the A350 can carry around 350 passengers and, on a single tank of fuel, cover a distance of over 14,000 kilometers. Demand for the A350 is high. Around 50 airlines have placed orders so far. The production rate averages around 10 of these aircraft per month. Airbus is one of Europe's most important companies, with around 52,000 employees over 16 locations. In Hamburg-Finkenwerder, this A380 is currently being fitted out. It requires 60 tons of interior furnishings and material that are delivered just in time to the site. The wiring of the jet is becoming increasingly complex, as passengers expect the latest technology at every seat.
Today we have tons of computers inside an aircraft just to entertain the passenger. The passenger wants to have seamless entertainment availabilities from home, in the car, in the terminal, inside the aircraft, up to his final destination, so that he can stream his movies or other entertainments. And this is a big challenge to incorporate this all into the aircraft, so that we have a safe operation and no interference with all the flight relevant systems which are necessary for safe operation of the aircraft.
Lars Fischer is making his way to the lower passenger deck. One of the storage compartments is causing problems.
So, we have the bracket in place. Now we can install the compartment. Are you ready? Can we start? Good.
One of the brackets didn't fit, as the holes drilled were outside the tolerance range. Using a replacement part, the storage compartment can now be mounted in position. Fitting out the interior of an aircraft still requires traditional manual skills.
The challenge at the beginning is that we need to have a clever sequence to assemble all the big monuments which are not fitting through the door. So they are splitted and we need to put them in pieces into the cabin and reassemble them inside the aircraft. In order not to block our progress, this is quite a challenging task to get them installed and then finished in the early days of our lead time here, so that we then continue with the further installations of seats and linings and head racks and all the other monuments and assemblies which are following.
Due to their size, the first class and business class seats won't fit through the door in one piece. So the fitters disassemble them first, outside the cabin.
On 3. Nikki, ready to pull? Okay, 1, 2, and up. Good. And now put it down carefully. And now slowly into the seat rails. That looks good.
The assembly of these mini suites starts with a base plate, which is connected to the seat rails with all the assemblies which are all already pre-installed from our suppliers. Then we are building up the side walls or the inner walls, so we are building it from the outside to the inside, and finally we are installing the seat itself, which is quite a heavy weight, and closing the compartment with the doors at the aisle side. So we are building it from the outside to the inside in order to reduce damages and be as efficient as we can.
The fitters have just 2 weeks left to complete the aircraft's interior. Now they are adjusting the overhead lighting.
After the assembly we have to do functional test of all the cabin systems, so we need to demonstrate also to the authorities that the systems are behaving like they are specified. So we are receiving requirements from the engineering, how to test it, and then we are executing this test or performing this test here on the aircraft.
In Hamburg, the giant planes receive their signature colors in the largest paint shop in the world. Today, an A380 is being spray painted for its new owner, the airline Emirates. The entire process lasts around 12 days. First comes the primer coat, then the top coat layers, and finally the clear coat. To cover the 4,000 square meter surface of the fuselage and both wings, the painters need around 1 ton of paint. The greatest challenge they face is in working simultaneously from telescopic platforms in order to apply the paint as evenly as possible.
So when we paint a 380, we apply way over a ton of paint altogether, of which about 600 kilograms stay on the aircraft. On the aircraft you've seen that we have painted, we have a layer of primer, a layer of intermediate coat, 3 layers of top coat, then we have what you see on decoration, the gold, the red, the green, and then 2 layers of a clear coat in addition. So quite a few layers. Maximum allowed thickness is 330 microns, so quite thin.
Today, team leaders René Rossmann and Matthias Henze are performing a quality control. They conduct their checks from a telescopic platform. This requires them to wear safety harnesses.
Final check is our final quality check before we do the customer acceptance. So what we are looking for is are there minor details that need rework, slight inaccuracies in aligning that will be touched up with a brush. We're looking for rests of tape, glue residues from tape that will be cleaned. We're also looking for inclusions or some matte areas that will be polished. Then we are looking for inclusions altogether. We have maximum amounts of inclusions we're allowed to have. All imperfections, we check if they are within the standards we're allowed to have or outside of the standards. If they're outside of the standards, they will be reworked.
The edges of the cockpit windows.
Yeah, there's still a bit of tape there.
I'll put that down. Let's make a note of all 3 on the left side.
Yeah.
That's 1 point.
Yeah.
There's some glue residue stuck to the cockpit windows. We'll make a note of that so it gets removed.
During the final check or also during the customer inspection, if we find something, we will write a so-called Form A, a snag sheet. So we will document what have we found, what have we done, and the inspector will stamp that it has been done. This is just for internal documentation. And if it's something bigger that has to be done at a later stage, which we cannot manage during the customer check, then the customer will write a QLB, and then we will provide a rework according to the QLB or provide a statement saying that it is within the limits.
Sometimes an insect finds its way into the workshop and gets stuck to the paintwork.
Any foreign objects sticking to the plane are an absolute no-go. We also have to check carefully that everything has been removed, such as the materials used for masking and taping the surface during painting.
The final result must meet the high expectations of the customers, and they are notoriously demanding. Entire planes have had to be repainted because the paint was applied too thickly. And the paintwork must also be able to withstand stress and weathering over a period of decades.
The expectations for an aircraft like this are extremely high. This paint can withstand temperature changes from over 50 degrees Celsius in Dubai to minus 50 degrees up at 30,000 feet. These are very demanding conditions, but it's good enough to survive that.
The spraying process has been successful, but the result is not yet perfect. The painters need to make some small cosmetic adjustments.
After the final check, if we have areas where we're not satisfied with the gloss, we can polish it, we can polish out inclusions, we can touch up edges around opening door edges and so on. And we do that during the customer check as well. If the customer has something where he says, that could be a bit better, he'd like to have this, then as long as it's within the drawing, within the specification, we will do that during the customer acceptance as well. We can do about 90% of the detailing during the check itself.
After roughly 6 hours, the quality check is complete and any mistakes have been fixed. Airbus builds planes for almost all airlines in the world. The airlines send their representatives to Hamburg, not only to pick up their new jets, but also to monitor the entire construction process. Many of them have even set up their own offices here. It's now time for the final inspection and handover, accompanied by reams of paperwork and capped off by the so-called customer acceptance flight. During this flight, representatives from the airline are joined by Airbus specialists. Today, Airbus test engineer Thomas Heidemann and his crew are going to take a detailed look at this new EasyJet aircraft. The experienced pilot and engineer begins with a visual inspection and checks whether all customer complaints have been fully dealt with. The ground crew has had to retighten several of the clamps.
The difference in between a line pilot and a test pilot, we don't transport persons or freight, we don't go cargo, we don't go anywhere. We go mostly from Finkenwerder back to Finkenwerder. Even if we fly sometimes 8-9 hours, we mostly come back to Finkenwerder or we go from Hamburg to Toulouse. The idea is to test the aircraft technically, whereas the expectation in an airline is to bring people from one position to another one.
Two additional pilots are on board to assist in the testing process. They begin by checking the systems and the engines while still on the ground. In a previous exercise, the pilots tested the procedure for aborting takeoff. EasyJet has asked Airbus to perform the test flight and document any issues. If the flight is successful, the airline will accept the plane. The test program, which lasts around 3 hours in total, puts the new plane through its paces. And from flight test engineer Thomas Heidemann and his two pilots, it demands the utmost concentration. Once the plane has reached its flying altitude, all the instruments, warning displays and reserve systems are activated, tested, and, if necessary, readjusted. Test engineer Heidemann connects his laptop to the onboard network in order to request and save system data. Then the next test takes place. The plane is flown at a banking position until flight control takes over.
During our flight control checks, we are checking the coordination of the ailerons and the spoilers and all other control surfaces to ensure that the coordination is correctly done. We are going to the maximum of 67 degrees in roll on the aircraft, which is equal to 2G. And we're doing as well pitch up and pitch down to the maximum of the aircraft, pitch up 30 degrees and pitch down for 15 degrees, to see that the limits are very well maintained by the flight control computer. The advantage of a fly-by-wire aircraft is that me as a pilot, I could go always to the extremes in roll or in loads without paying attention on the G-meter, where I would always stop a little bit before the limit. Here I go to the limit and the control computer applies the limit for me. And especially we check as well that all electrical connectors well racked, and with the G-loads you can ensure that they are not dropping off the rack or connectors are going to open due to the G-loads.
The test pilots aboard the A320 have to be a bit more careful. Under the direction of test engineer Thomas Heidemann, the brand new jetliner is going through some final tests before being delivered to the customer.
Ready? Then we depress now. Please. Pack 1. Check. Pack 2. Check. Both packs providing the pressure of the cabin pressure for the aircraft are going to be switched off now, and automatically the outflow valve, this is a big valve in the rear of the aircraft, which is going to close drastically to 100%, and now we're losing through the holes of the aircraft more and more the cabin pressure. And we will increase that even by opening some holes, avionics ventilation and blower extract, check, blower and extract, off. Now we get a higher leak rate. The vertical speed in the cabin goes up to 1400 feet, even higher, and the cabin pressure, which we can see delta P77, is going to drop down. On the right hand side, the cabin altitude is going to increase from 6,000 feet to finally 11,300 feet. At 11,300 feet, the cabin is going to check the quality of the non-textile floors, which were not good on the last flight.
In an actual emergency, the loss in cabin pressure could kick in straight away. Here it's occurring under controlled conditions. The parameters for the next part of the test have been established. Antonio Fernandez checks all the moving parts in the cabin, from cupboard doors to luggage compartments and hatches. These can become distorted during flight and make irritating noises, as can the seats.
Generell teste ich ja auch ob die Sitze.
I test whether all the seats are securely fastened. Then I check the individual controls, lights and air vent nozzles. I make sure everything is working, that air is really coming out. During the flight, a lot of things can move, like the covers here and the doors. They may stop opening and closing properly, so they would need to be readjusted.
Dann nicht mehr so vernünftig auf oder zugehen, dann müssen die nochmal neu eingestellt werden.
Fernandez also checks whether air bubbles are formed under the floor paneling.
We're now checking the floor covering. If air has got trapped underneath it because the covering wasn't glued properly, then the air would expand and we would have a misshapen floor lining. It's basically a sheet of plastic that's been glued on to keep water from seeping onto the underlying structure.
Der Feuchtbereich das Wasser von der unteren Struktur abhält.
Yeah, that looks good actually.
So now we're ascending and going to the next altitude.
The tests are the last major milestone before the plane is handed over. If everything goes smoothly, the airline will take receipt of the aircraft the following day. This is carried out officially with the transfer of the ownership rights, the so-called transfer of title. Before this, the airline pays the final installment of the agreed purchase price. The landing approach at Hamburg-Finkenwerder. For the crew, this is always the best moment of the test flight. After 3 hours in the air, Thomas Heidemann can summarize his findings.
Statistically, the aircraft flies 1.5 times. That means not each of the aircraft have to fly 2 times. They finish their program when we do a first flight program. And the next flight after the first flight is the customer acceptance flight. The customer will take on flight number 3 the aircraft back home to their home bases then.
The A380 was once considered the passenger aircraft of the future. Yet the initial euphoria has vanished. While the impressive double-deck jetliner remains a favorite of passengers, a lack of orders ultimately doomed the project. Airbus was forced to reduce its yearly output of 30 aircraft to just 6. The Arabian airline Emirates has the largest fleet of A380s. Today, their representative Armin Java is here to take receipt of one more A380, priced officially at 500 million euros. Airbus is represented by customer manager Ralf Pech. He looks on as the customer marks even the smallest cosmetic error with a strip of green tape.
Yes, we are here in the delivery of the MSN 250 and we have the customer acceptance program currently in progress. We start, the program itself is a program which lasts 9 days for Emirates. We start at day 1 with the external and cabin checks, so customer is invited to have a final look to the aircraft and hopefully to find everything to his satisfaction. On the day 2 of the delivery program, we do the so-called customer acceptance flight. Means that the Airbus will be flown by an airline pilot sitting on the left seat with an Airbus pilot in charge to test all the systems, to do maneuvers, whatever. This is in the so-called acceptance program notified.
Armin Java is looking for mistakes, and of course, the customer is always right. His objections are written down in detail and must all be resolved within a matter of days. Here, markings are missing.
Reassess this area. The shot peening, you mean, or
is it shot peening?
That's shot peening. That's, yeah, I'm sure. I have very much experience with shot peening, and this is purely shot peening. Yeah. But you can see it. I mean, you can see it. You can see it from here. Yeah, that's purely shot peening. Yeah, that's no issue.
The Emirates quality controller was present during the entire construction process. He knows the plane well and has a lot of faith in the Airbus crew.
At this stage of the aircraft, it's more minor stuff. It's very rare that we will find something very significant, because coming into a delivery, the aircraft has been inspected several times by our staff as well as the Airbus quality. So it's just a final check around to make sure that at the time of delivery everything is perfect.
Typically, 3/4 of the time spent on customer acceptance for the A380 relates to the ever more complex interior furnishings in the business and first class sections of the plane. This includes the staircase with its luxurious fittings. Even the tiniest scratch is grounds for complaint.
Here we are in the upper deck. This is the premium segment of the cabin with first class, business class, and here now we are in the area of the bar area, and many people are meeting here during flight, and it's a comfortable zone for people who flying on this aircraft. So, and therefore we need to guarantee for us and also for the customer high quality standard.
While waiting for its transfer flight, the aircraft remains parked on an isolated part of the tarmac. Airbus employees are now only allowed on board with the customer's permission. Once the airline has transferred the final installment and Airbus has been paid in full, there is nothing left to do. The Emirates pilots assume control of their new A380. The tower provides clearance for takeoff. To the delight of its loyal passengers, the majestic giant takes to the skies.